Hello guys, we are back again with another video lesson. In a previous lesson, we stopped here in practice 3B, question 2. We solved question 1 and the sample problem 3B. Now we are going to solve question 2 in practice 3B about the pressure. Pressure is equal to force divided by the area. Is the force per unit area. Measured in Newton per meter square or measured in the Pascal. The equivalent unit of Pascal is Newton per meter square. So the SI unit of pressure is equal to force over area. If the pressure is unknown, and to determine the amount of the pressure, you have to use this relation, force divided by area. But to determine the amount of the force when pressure and area are given in the question, so you can rearrange this equation like this. Force is equal to pressure times area. And of course, you can rearrange the equation to determine pressure, force, and area. To determine area, you have to use this relation, force divided by pressure. Question 2 says, a 1.5 meter wide by 2.5 meter long waterbed. So the waterbed is, this is question 2. So the waterbed is 1.5 meter wide. So its width is equal to 1.5 meter. Okay, so this is the width of the waterbed. And here is 1.5 meter and 2.5 meter long. 2.5 meter long. What is this? This is the waterbed. Okay, this is waterbed. Okay, so its width is equal to, so its length is equal to 2.5 meter. So the weight of the waterbed is, it means that force, the gravitational force affecting on this waterbed, and it produces the amount of the pressure in this case. The amount of the force or the weight is equal to, what is the force here? Fg, 1025 Newton. Find the pressure that the waterbed exerts on the floor. Okay, assume that the entire lower surface of the bed makes contact with the floor. Okay, so what is unknown? Pressure is unknown. To determine the amount of the pressure in this question, pressure is equal to what? Is equal to force divided by area. Okay, now guys, look, do we have force? Yes, we have force. The force here is gravitational force, it doesn't matter. Okay, do we have area? No, we don't have area. So, but instead of area, we have length and width. As you know, the area of the rectangular is equal to length times width. How can you determine the area of the rectangle? Length by width. Okay, length times width. Look, area is equal to what? Length times width. When does this equation can be used to determine area? For the rectangular shape. If the shape, like for example, is square, how can you determine the area of the square? Of course, by using the relation of the area of the square, which is equal to L square or L times L, you can determine the area of the square shape. Okay, so if the question, in the question, the radius is given, to determine the area of the circle, the radius must be given or diameter must be given. If the diameter is given, you have to convert to radius. After that, you can find area. But if the radius is given, so you have to convert the radius to the area directly by pi r square. But you have to make sure that the radius or the diameter must be given in meter. Okay, in the case when it's given in centimeter or millimeter, you have to convert to meter. After that, you can find the area. So area is equal to what? Do we have length? Yes, 2.5 times. Do we have width? Yes, 1.5. Multiply them, so you can find the area of the waterbed that the gravitational force exerted on it by 1025 Newton. 2.5 times 1.5 is equal to 3.75 what? Meter square. Meter square. Why? Because length measured in meter, width meter, meter times meter is meter square. Okay. So now you can replace into the equation, and of course you can get the answer of the pressure. Force 1025 divided by 3.75. Pressure is equal to what? Pressure is equal to, now I'm going to calculate 1025 divided by 3.75. is equal to 273.33 what? Pascal. Pascal or Newton per meter square. Both are correct. Okay? Both are correct. Question 2, 2 point, or you can say 2.7 times 10 power 2. It doesn't matter, guys. By scientific notation, P is equal to what? 2.7 times what? How many digits remain? 2 times 10 power 2 Pascal. Okay, both are correct. 2.7 times 2 or 273.3 Pascal is the same thing. Okay. Question 3. Look at question 3. A person rides up a lift to a mountain top, but the person's ears fail to the pop. That is, the pressure of the inner ear does not equalize with the outside atmosphere. The radius of each eardrum is 0.4 centimeter. This is question 3, guys. Radius is equal to 0.4 centimeter. You have to convert this centimeter to meter. How? Divided by 100 or multiply 10 power negative 2. Both are correct. R is equal to what? If you divide it by 100, we will get this number. Okay. 4 times 10 power negative 3 meter. Okay. Or 0.4 times 10 power negative 2 meter. Is this? It doesn't matter. It's the same thing. Okay. This is the amount of the radius. The pressure of the atmosphere drops from, the pressure dropped from what? P1 is equal to 1.01 times 10 power 5 Pascal. Okay. And drops at the bottom of the lift to 998. Okay. 9, So drop it from what, guys? Look, P1 0.998 times 10 power 5 Pascal, and P2 at the bottom of the mountain is 1.01 times 10 power 5 Pascal. Okay. A, we have two unknowns here. A, what is the pressure difference between the inner and the outer ear at the top of the mountain? At the top of the mountain, we have inner and outer pressure. Okay, to determine the pressure difference between the inner and outer, so we have to find the difference in pressure, P outer minus P inner. The difference in pressure, P outer, 1.01 times 10 power 5 minus the pressure in the inner ears is equal to 0.998 times 10 power 5. The difference in pressure, so we have to subtract them. Subtract these two pressures, the outer pressure and the inner pressure. Okay. 1.01 times shift to log 10 power 5 minus 0.998 times shift to log 10 power 5 is equal to 1.2 or 1,200 Pascal. Okay, or 1.2 times 10 power 3 Pascal is the same. Both are correct. The difference in pressure is equal to 1.2 times 10 power 3 Pascal. This is what? This is the pressure difference between the inner and outer air at the top of the mountain. Okay. Branch B, what is unknown? What is the magnitude of the net force? Net force is equal to what? The force like on the outer minus force of inner ears. Okay. The force, outer force is equal to what? You have to find it. P outer is equal to what? The force, the outer force divided by area. Area is the same at the bottom of the mountain and at the top of the mountain. The outer force is unknown. How can you rearrange, guys, to determine this force? Of course, we can rearrange this equation to find what? The force of outer ears. Okay, is equal to what? P outer times area. Okay. So the outer force of the air is equal to what? Pressure. Do we have pressure? Yeah, 1.01 times 10 power 5 times. Do we have area? Guys, look. Do we have area? No, we don't have area. Look at this question. Do we have radius? Yes, we have radius. If the radius is given, how can you determine area? Area is equal to pi r squared. Pi is constant. R 4 times 10 power negative 3 squared. Area is equal to what? By calculator. 4 is 16. 16 times 3.14 is equal to 50 times shift log 10 power negative 6 is equal to 5. I got 502 times 10 power negative 5 meters square. This is area. How did we get the area? How we found the area? By the radius. Because the radius is given, you can determine the amount of the area, pi r square. Okay, let's go back to the questions. F outer is, do we have area? We didn't, but we found. Area was 502 times 10 power negative 5. The outer force is equal to what? The answer multiply 1.01 times shifted log 10 power 5 is equal to 5.074 or 574 Newton. This is the outer force. The inner force, okay, I found the outer force, okay? This is net force. 5.074 minus the inner force is equal to what? Inner force is equal to P inner times area, the same area. P, do we have P inner? Yes. 0.998 times 10 power 5 times the same area, 5.02 times 10 power negative 5. The inner force is equal to what? 0.998 times shift log 10 power 5 times 5.02 times shift to log 10 power negative 5. I got this number 5.001 Newton. Okay, so we can subtract these two numbers. 5.074 minus answer, I got 0.06 is equal to 0.06 Newton. The net force is equal to 0.06 Newton, or 6 times 10 power negative 2 Newton. Both are correct. 6 times 10 power negative 2 Newton. So in this way, you can determine the net force and the difference in pressure in this question. Okay, guys, in this section, we have another topic about the pressure. We studied the Pascal's principle. When the pressure applied on a fluid, this pressure transmitted equally throughout the walls. Like, for example, in a hydraulic lift, of course, the force exerted on a small piston exerts a pressure, P1. So this pressure exerts the fluid and produces a large force that can be used to raising a heavy object or to lift a heavy object like a car. So in this way, we can determine the amount of the force that that can lift and raise the heavy object. Another topic in this section, pressure varies with the depth in a fluid. Pressure varies with the depth in a fluid. What do you mean by pressure varies with the depth of the fluid? It means that the pressure is not equal in the container at each point, like at each level. Like, for example, if you have a container, okay, and this container is filled with water, and if you have 3 small holes, okay, so this is the depth of the container. Which one has more depth? This is hole number 1, 2, 3. The hole number 3 is has more depth than the number 1 and number 2, and of course the pressure for the third hole, the hole number 3, is more than pressure in hole number 2 and hole number 1. Okay, so the reason that the pressure is directly proportional to the depth. The pressure is directly proportional to the more depth of the container has more pressure. Okay, so at which point in these 3 points, which one has more pressure? The point has more depth, has more pressure. So the pressure is directly proportional to the depth. Okay. As a submarine dives deeper in the water, the pressure of the water against the hull of the submarine increases. As the depth increases of the ocean, the pressure also increases. So the pressure is directly proportional to the depth and the height of the ocean or any other container. Okay, so the hull must be strong enough to withstand large pressure. So the water pressure increases with the depth. What happens to the water pressure? Increases with what? With the depth, because the water at a given depth must support the weight of the water above it. Okay, so we have this equation. How can we determine the pressure of the fluid? P fluid is equal to what? Is equal to density times gravity times height. Okay, this height, it means that depth. Okay, what do you mean by the height? H is depth. Okay, so what is P fluid? Is fluid pressure. Is a fluid pressure. Okay, what is this? This is fluid pressure measured in what? Pascal. What is this? Density. Okay, fluid's density. This is gravity, which is constant. Meter per second square. Fluid density kilogram per meter cube. And this is meter per second square. H, what do you mean by this H? This is height or depth. The depth of the container or ocean. Measured in what? Measured in meter. Okay? So according to this equation, we can determine the pressure of the fluid in a container. The pressure of the fluid in a container, which is called the gauge pressure, we can determine in this by using this equation. P fluid it means that gauge pressure. Okay, what do you mean by fluid pressure? It means that gauge pressure. It has 2 names. Okay, fluid pressure or gauge pressure, it doesn't matter, both are correct. Okay, and both of them is equal to what? Density, gravity, and height. Okay, now I'm going to prove this equation. The pressure of the fluid is equal to what? Equal to density times gravity times height. How did we get this equation? According to this equation, pressure is equal to what? Pressure is equal to force of the fluid. Force, Fg divided by what? By area. Force divided by area. Force is equal to what? Force is equal to mg over area. Okay? So if you open mass, according to this relation, if you remember, density is not equal to mass per volume. So how about mass? Mass is equal to, of course, mass is equal to density times volume. Okay? And instead of this mass, write down density times volume, and gravity, it remain over area. Over what? Over area. Okay? Guys, look. Density times, instead of volume, if you remember, volume is equal to what? Length times width times height. How about area? Area is equal to what? Length times width. Okay? And instead of the volume, write down L times width times height. What does remain? Gravity remain. And instead of area, write down what? L times width. L with L cancel. Width with width cancel. What does remain? Rho GH. Density, gravity, height. So that is why fluid pressure is equal to what? What does remain? Density, gravity, and height. In this equation, of course, you can determine the amount of the fluid's pressure. This equation can be used only to find what? To find fluid pressure only. Fluid pressure. Okay? But guys, look. if you have a container, okay, and the top of the container is open, okay, so the top of the container is open, how many pressures do we have at the bottom of this container? For example, if the object is here, if someone stands at at the below the container, okay, when someone stands here, okay, how many pressure exerted on this object? The fluid pressure, the pressure of a fluid, and atmospheric pressure, okay, because the top of the container is open like ocean. The object at the bottom of the ocean, how many pressure exerted on the of the divers at the bottom of the ocean? There are two pressures: the fluid pressure, the pressure of the ocean, fluid pressure, and the pressure of the atmospheric, okay, atmospheric pressure. So, but for the closed container, if the top is closed, okay, for the closed container, if this container is filled with water, okay, how many pressure exerted on this object? Only fluid pressure. Only fluid pressure. We don't have atmospheric pressure here. For the closed container, atmospheric pressure at the bottom of the container is what? Is 0. But for the open container, there are two pressures. There are two pressures: atmospheric pressure and fluid pressure. When the top is open, we have two pressures. So to find the absolute pressure, which means that the net pressure, so we have to use this equation: fluid pressure plus atmospheric pressure. P absolute. What is P absolute? The total pressure at the bottom of the container when the container is open. Okay, when the container is open. Absolute pressure is equal to what? P fluid is equal to what? Rho G H plus what? P naught. Okay, or we can say P absolute. Okay, it doesn't matter, both are correct. P atmospheric plus what? P fluid. P absolute, P atmospheric pressure plus rho G H. This equation can be used when the top of the container is open and there are two pressure: atmospheric pressure and fluid pressure. This equation is valid only if the density is the same throughout the fluid, the same density. Okay, the pressure in the equation above is referred as the gauge pressure. What is this? This is gauge pressure, fluid pressure or gauge pressure. What does fluid pressure depend on? What does fluid pressure depend on? According to this equation, fluid pressure is equal to density, gravity, height. What does fluid pressure or gauge pressure depend on? Depend on the density of the liquid or fluid, gravity, and height of the container or depth of the container. Okay. Gauge pressure is actually the total pressure minus the atmospheric pressure. By using the symbol PO for the atmospheric pressure at the surface, we can express the total pressure, absolute pressure. The total pressure is what? Absolute pressure. How can you determine the absolute pressure? Absolute pressure, it means that total pressure is equal to what? P atmospheric plus rho G H. If the question asks us to find the absolute pressure, you have to use this relation. Okay? But if the question asks us to find the pressure of the fluid only, P fluid is equal to what? This is different from the absolute pressure. Here we have only the pressure for the fluid is equal to rho GH. What is the difference between these two equations? The first equation can be used to determine the absolute pressure, which is total pressure. Okay? Which means total pressure. P naught plus rho GH. But fluid pressure can be used, of course, to determine the pressure of the fluid, which is equal to rho GH, density, gravity, and height. Atmospheric pressure, we studied the weight of the air in the upper portion of the Earth's atmosphere exerts a pressure on the line of the air below. At sea level, P atmosphere is equal to what? 1.01 times 10 power 5 Pascal. So you have to keep in your mind this value of the atmospheric pressure at sea level. Okay. The force it exerts on our body, assuming the body are 2 meters square, is exerted extremely large, on the order 200,000 Newton per meter per 2 meters square, but per 1 meter square is approximately 100,000 meters square Newton. So the force on 1 meter square is 100,000 Newton. So how can we exist under this huge force and the pressure? Because our body consists of the cavities and the tissues, and the cells. So inside the cells there is a hole. And each cell in our body has the pressure. Okay, so that is why the outer pressure is equal to the inner pressure on our body. So that is why this huge amount of the pressure does not exert and cannot collapse our body. Okay, so because the pressure acts in all directions with the same magnitude. Okay, and the atmospheric pressure is equal to the inner pressure of our body that produced by the cells, because you know that inside our cells and tissues there is a liquid part, fluid, which is a cytoplasm, and all the organelles, the other organelles can streaming because of the cytoplasm inside the cell to do their functions. Okay, how can we exist under such tremendous forces without our body collapsing? As I told you, our body cavities and tissues are permeated with the fluid and gases that are pushing outward with the pressure equal that of the atmospheric pressure. Why the roof of a building does not collapse under the tremendous pressure exerted by our atmosphere? Because the pressure inside the building is approximately equal to the pressure outside the building. Okay, so like for example, if you have a building like this, this is the atmospheric pressure, 100,000 Newton per 1 meter square. Why this building does not collapse? Because this pressure acting in all directions. Okay, so this pressure is acting in all directions, so that is why the building does not collapse. Why a mercury used in a mercury barometer? In barometer as a device can be used. The height of the mercury in the tube of the barometer indicates the atmospheric pressure. Okay, the mercury barometer can be used to measure the atmospheric pressure. Okay, this is empty vacuum and this is mercury. Why mercury can be used or is used in mercury barometer? There are a couple of keys and a couple of reasons. Because it has high density. Mercury is such denser than other liquids like water. The density allows a manageable barometer size. If you use the water instead, the barometer would need to be about 13.6 times taller to measure the same pressure. So that is why the mercury is better than the water. Okay, and also it's easy to read. Mercury is a shiny liquid, making it easier to see the level in the barometer tube and take precise measurements of air pressures. Kinetic theory of the gases and gas pressures. The kinetic theory of the gases also we will study in chapter 4, inshallah, section 2 in chapter 4. The kinetic energy of the gases is directly proportional to the speed of the particles, and the speed of the particles increases by increasing the temperature. So when the temperature gets higher, the speed movement becomes more and more, and when the speed of the atoms becomes more, it means that undergoes a more kinetic energy. Why? Because the kinetic energy depends on mass and the square velocity of the particles. So what is the kinetic energy? The kinetic theory of the gas is a model that explains the behavior of the gas on a microscopic level. Some knows about the kinetic theory of the gas and pressure. Gas are made of tiny particles. These particles can atoms or molecules. Depending on the gas, they are much too smaller to see with the even most powerful microscope. Constant random motion. These particles are constantly moving around in a random directions at a very high speed. With what? With a very high speed. Why? Because there is a separation between the particles. Collisions. The particles constantly collide with each other in the air and with the walls of the container holding the gas. Pressure from collisions. The pressure of a gas is caused by the force exerted. This tiny particle colliding with the wall of the container. More collision and faster moving particles mean a higher pressure. Temperature and kinetic energy. The temperature of gas is related to the average kinetic energy, okay, of the particles. Higher temperature means particles are moving faster on average kinetic energy. Why? Because kinetic energy is equal to what? 1 over 2 mv squared. So guys, when temperature gets more, what happened to the velocity? The velocity also gets more. So when the velocity gets more, what happened to the kinetic energy? Kinetic energy also increases. Why? Because the velocity is square. It has more effective. Okay? Because kinetic energy depends on mass and the square velocity. When the velocity becomes more, kinetic energy, of course, becomes more. Look at sample problem 3C. Calculate the absolute pressure. Guys, how can you determine the absolute pressure? Question is sample problem. (3C). Question sample problem 3C. What is unknown? Absolute pressure. Sorry, absolute pressure is unknown. What is unknown? Absolute pressure. P absolute is unknown. Okay? At an ocean, guys, ocean, the top of the ocean is already open. Okay? This is not container. This is ocean. The top of the ocean is always assume that it's open. Okay? With the depth 1 times 10 power 3 meter. What is this? This is height, or this is the depth of the ocean. The depth, the symbol of depth is height. The height, it means that the depth of the ocean. What do you mean by height? Depth. Okay? Depth is equal to what? It means that height. The symbol of depth is height. Height is 1 times 10 power 3 or 1000 meter. Okay? 1000 meter. Assume that the density of the water is of the ocean, the seawater, that is density must be given 0.25 times 10 power 3 kilogram per meter cube. And P naught is given, but when P naught is not given, you have to memorize this atmospheric pressure. Sometimes it is not given in the question. Okay, atmospheric pressure, I will not give you, guys, be careful. 1.01 times 10 power 3 Pascal. Okay, for every solving question, guys, you have to write down the given value and the unknown value. Okay, how many unknowns do we have? Only absolute pressure. How many given values do we have? We have depth, which is height, density, and atmospheric pressure. Which equation can be used to determine the absolute pressure? Guys, look, which equation can be used to determine the absolute pressure? This equation. Okay, the first equation, P naught plus rho g h. Look, so you have to write down the equation of absolute pressure, which is equal to P naught plus rho g h. P absolute is equal to P naught constant 1.01 times 10 power 5 plus the density. Sorry, we don't have enough space here. Okay, now I'm going to write down here. Look, be with me. Guys, look. How can you determine absolute pressure? Absolute pressure is equal to P naught plus rho g h. Substitute and replace the number here, 1.01 times 10 power 5 plus density 1.025 times 10 power 3 times 9.81 times 1000. So by your calculator, so you can find out the total pressure or the absolute pressure. Okay, 1.025 times 1000 times 9.81 times 1000. Okay, and plus 1.01 times at first you have to find open this bracket. After that you can add with this number, shift and log, 10 power 5. So I got this number 1.01 1.02 times 10 power 7 Pascal. Okay, I got the absolute pressure 1.02 times 10 power 7 Pascal. Okay, exactly is the same thing. 1.02 times 10 power 7 Pascal. In this way, of course, you can determine the absolute pressure at the bottom of the ocean with a depth 1,000 meters. Question 1, practice 3C. So you can take a photo and you can screen this answer. Practice 3C. Question 1. The marine range in the Pacific Ocean is about 11 kilometers deep. Guys, listen carefully. The depth is given, height. Height is equal to 11 kilometers. Guys, not allowed solving question with kilometer. You have to convert. The SI unit of height is meter, not kilometer. Okay? So that is why you have to directly convert this 11 kilometer to what? To meter. Height is equal to what? 11 times 1,000 times 10 power 3 or times 1,000 is the same thing. Which is equal to what? 11,000 meter. What is this? This is the height of the ocean and depth of the ocean. 11,000 meter. Okay? If atmospheric pressure at sea level, this is atmospheric pressure at sea level, 1.01 times 10 power 5 Pascal. How much pressure would a submarine need to be able to withstand to reach this depth at the bottom of the depth? What is or how much pressure would the submarine need to be able to withstand? So what is unknown at the bottom of the ocean? Absolute pressure is unknown. What is unknown? Absolute pressure. How did you know this is absolute pressure? Because the question says how much pressure? Which pressure? Fluid pressure or atmospheric pressure or absolute pressure? Absolute pressure. Why? Because the question says how much pressure would the submarine need to be able to withstand to what? To what? To reach this depth at the bottom of this ocean. Okay? Absolute pressure is unknown. How can you determine the absolute pressure? As usual, you have to write down the equation of absolute pressure. P absolute is equal to P atmosphere plus rho GH. P absolute is equal to what? P naught 1.01 times 10 power 5 plus density of the ocean. It must be given in table 3.1. The density of the ocean 1.02 times 10 power 3. Okay? 1.025 times 10 power 3 times 9.81 times 11,000. 11,000. Okay? So, guys, look. In this way, you can determine the absolute pressure of the submarine at the bottom of the ocean. P absolute is equal to what? By using your calculator, you can determine the absolute pressure at the bottom of this ocean. 1.025 times 10 power 3 times 9.81 times 11,000, okay, plus 1.01 times shift and log 10 power 5. Guys, I got 1.01, 1, 2, 3, 4, 5, 6, 8. 1.1 times 10 power 8 Pascal. Why this absolute pressure is more than the absolute pressure of a previous question? Why the absolute pressure of question 1 in practice 3C more than the absolute pressure of the sample problem? Because it has more height. The height here is what? 1,000 meters. Okay? But in this question, the height is 11,000 meters. When height gets more, what happens to the pressure? Pressure also gets more. Why? Because the relation between pressure, rho GH, pressure with height is directly proportional at constant density and gravity. In the question between practice and the sample problem, they have the same gravity and they have the same density, but different height. More height has more pressure. Question 2, look at question 2, guys. Very good question, be careful. A container is filled with water to a depth of 20 centimeters. A container is filled with what? With water to the depth of 20 centimeters. The HW, what do you mean by HW? The height of water is equal to what? 20 centimeters which is equal to 0.2 meter divided by 100. Convert centimeter to meter. The height of water is what? 0.2 meter. And on the top of the water flows 30 centimeter thick layer of oil. So we have height of oil. We have two fluids, guys. 30 centimeter, which is equal to 0.3 meter. Okay? This is the height of the oil. Now we have a container. Guys, look. The top of the container is open. So there is atmospheric pressure. Okay? How many centimeter layer of water do we have in this container? We have 20 centimeter. Okay? We have 20 centimeter layer of water. Okay? What is this? This is water and water. Okay? And how many centimeter thick layer of oil do we have? We have a 30 centimeter thick layer of oil flows at the top of the water. Okay? This is oil. Here we have 0.2 meter height, and for the oil we have 0.3 meter thick layer of the oil. Okay, float at the top of the water. Why the oil flows at the top of the water? Because the which one has more density? Which one is denser? Absolutely, the water is denser than the oil. Why? Because the oil is floating at the top of the water. Okay, so which one sinks? Water. In this case, the water sinks in the oil. So these two fluids can never mix to each other because different in density. Because different of what? Different of densities. Okay, they have a different density. So the density of the water is equal to what? The density of water is 1 times 10 power 3 kilogram constant meter cube, and the density of oil was given 0.7 times 10 power 3 kilogram per meter cube. Okay, what is the pressure at the surface of the water? What is unknown, branch A? The pressure at the surface of the water. The pressure here, okay? At the surface of the water, how many pressure affecting the surface of the water? Only the oil's pressure and atmospheric pressure. How many pressures do we have at the surface of the water? There is two pressures. The pressure of the oil and the pressure of the atmospheric pressure. For the branch A, we do not count the pressure of the water. Why? Because we have to find the pressure at the surface of the water. At the surface of the water, we don't have the pressure of the water. Only the pressure of the oil and atmospheric pressure. Branch A, to find the to find the pressure at the surface of the water, P absolute is unknown, which is equal to P naught, the atmospheric pressure, because the container is open at the top, rho GH. P absolute at the surface of the water is equal to 1.01 times 10 power 5 plus the density of fresh water is 1 times 10 power 3 times 9.81 times height of what? Of oil. So we have to use height of oil. Height of what? Of oil. 0.3. Okay? So this is absolute pressure at the surface of the water is equal to, now I'm going to calculate. Okay? 1 times 10 power 3 times 9.81 times 0.3 plus 1.01 times shift log 10 power 5. I got this number. 1.04 times 10 power 5 Pascal. What is this? This is absolute pressure at the surface of the water. This is what? Absolute pressure at the surface of water, okay? At the surface of the water, okay? And branch B, guys, what is the absolute pressure at the bottom of the container? At the bottom of the container, we have container, 30 centimeter oil and 20 centimeter of water. so there is the atmospheric pressure at the top of the container. Okay, so at the surface of the water only we have the pressure of the oil and absolute the atmospheric pressure. But at the bottom of the container, guys, how many pressures do we have? We have the oil's pressure and also the water's pressure. Okay, so that is why we have to find the absolute pressure for the water, and then we have to add with the absolute pressure at the surface of the water to find the absolute pressure at the bottom of the container. Branch B, what is unknown? P absolute at the bottom of the container. At the bottom of the container, P absolute at the bottom of the container is equal to P absolute of oil plus P absolute of what? Of water. Do we have P absolute of the oil? Yes, we found it. This is P absolute of the oil. P absolute of what? Of oil. Okay. Now we have to find the absolute pressure for the water. Okay. Absolute pressure for the water is equal to what? P naught plus rho g h of water. P absolute, substitute number 1.01 times 10 power 5 plus 1 times 10 power 3, 9.81. Height of water is equal to 0.2. In this way, of course, you can determine the absolute pressure of the water, which is equal to 1 times 10 power 3 times 9.81 times 0.2 and plus 1.01 times shifted log 10 power 5. I got 1.03 times 10 power 5. Okay. Pascal. Now we have to substitute to the total absolute pressure, which is equal to the P absolute of oil plus P absolute of water. Oil and water. P absolute is equal to what? For the oil is equal to 1.04. 1.04 times 10 power 5 plus 1.03 times 10 power 5, which is equal to, we have to add up this two number. Okay, 1.04 plus 1.03, I got 2.07 times 10 power 5 Pascal. This is 2.07 or 2.8, it doesn't matter. Okay, 2.08 times 10 power 5 Pascal at the bottom of the container or at the bottom of the container. Okay, so in this way you can solve this question, both branches, branch A and branch B. Question 3, guys, look. A beaker containing a mercury. What is the type of the fluid? Mercury is placed inside a vacuum chamber. Guys, be careful. In a vacuum chamber, atmospheric pressure is 0 in a laboratory. When does absolute atmospheric pressure is equal to 0? In a vacuum chamber. In where? In a vacuum chamber. In a vacuum, there is no atmospheric pressure. In the vacuum chamber, guys, listen carefully. When does P naught is equal to 0 in a vacuum? When there is no particles. If there is no particle, there is no atmospheric pressure. Okay. In a vacuum chamber, the atmospheric pressure is 0. The pressure at the bottom of the beaker, and question 3, PO 0. Why? Because vacuum. Okay. And P absolute at the bottom of the container is equal to what? 2.7 times 10 power 4 Pascal. Okay, this is absolute pressure at the bottom of the container, at the bottom of the container. Okay, what is the height of the mercury in the beaker? What is height? Height is unknown. Okay, so there is a hint here. Look at table 3.1 about the think carefully about what the value is for atmospheric pressure. 0. Why? Because there is empty and there is no particles, and the density of the mercury is, it should be given. Okay, the student are not required to memorize the density of the mercury, only the density of the fresh water you have to know. Okay, now I'm going to tell you the density of mercury, which is equal to the density of mercury must given in the question. Look, the density of mercury is 13.6 times 10 power 3. 13, density of mercury 13.6 times 10 power 3 kilogram per meter cube. This is the density of mercury. It must be given in the question. Okay, don't memorize this density. Only the density of fresh water and the density of the air you have to memorize. Okay, guys. Question 3 in practice 3C. The height is unknown. How can you determine height? At first, you have to write down the equation. The equation of the absolute pressure is equal to what? P absolute is equal to what? P atmosphere plus rho GH. Do we have P absolute? Yes, we have it. 2.7 times 10 power 4 is equal to P atmosphere 0. Why 0? Because it is vacuum chamber. Plus density of the mercury 13.6 times 10 power 3 times 9.81 times height is unknown, guys. Bring down this number. 10 power 4 is equal to 0 and plus is equal to the same thing. Okay, 13.6 times 13.6 times 10 power 3 times 9.81. I got 133,416 times h. H is equal to what? Make a fraction. What we have with the h? 133,416, and we have 2.7 times 10 power 4 here. Height is equal to what? 2,700 divided by what? Divided by 133,416. I got 0.2 meter. So the height of this chamber, this tube or this beaker is 0.2 meter. Okay, this is a vacuum. There is a mercury, and here is what? Vacuum. There is no atmospheric pressure, 0. Okay, so we found this height, the height of the beaker in this practice, in this question, which is 0.2 meter. Guys, look at question 4. Calculate the depth in the ocean. Calculate question 4. What do you mean by calculate the depth in the ocean? Height is unknown. What is unknown? Height is unknown. At which the pressure is 3 times atmospheric pressure. Pressure is 3 times atmospheric pressure. At the bottom of the ocean, P absolute is equal to 3 times P naught. How did you know? Because it was mentioned in the question. Calculate the depth, height is unknown, of the in the ocean, at which pressure, it means that absolute pressure is equal to 3 times what? Atmospheric pressure. 3 times P naught. So indirectly we have absolute pressure. The absolute pressure was not given directly, but it was given indirectly. P absolute is equal to 3 times P naught, and all we know that P naught is equal to what? 1.01 times 10 power 5 Pascal. Okay, now how can we calculate the depth of this ocean? Now I'm gonna solve. Okay, guys, look. To determine the depth of the ocean, it means that height is unknown. So write down the equation of absolute pressure. Absolute pressure is equal to what? Is equal to P atmospheric plus rho GH. P absolute, do we have P absolute? No, we have 3 P naught. And instead of P absolute, write down 3 P naught is equal to P naught plus rho GH. Rearrange this equation. Move the atmospheric pressure to the other side. It becomes negative. Okay, here is positive, and when we move to the other side, of course, becomes negative. Plus rho GH. 3 P naught minus P naught, 1 P naught. is equal to 2 P naught rho GH. So you can rearrange, guys, look, you can rearrange this equation. What is unknown? Height. Height is unknown. What we have with the height? Rho and G. What is remain? 2 times P naught. 2 times P naught, 2 times 1.01 times 10 power 5. Density of the ocean 1.025 times 10 power 3 times 9.81. So the height of the ocean is equal to, now I'm going to calculate, 2 times 10 power 5 divided by bracket 1.025 times 1000 times 9.81. Close the bracket. I got 20, guys. 20 meter. This is the height of the ocean. Okay. So we finished it. The practice 3C. Okay. Guys, that's all for today. Thank you for listening. And I hope you get benefited from my lessons. And you have to listen carefully the videos. Have a good time.